Alright, so in this video we're going to take a look at how to use your graphing calculator, and we're going to use it to find function values. We're going to use the insert key. We're going to take a look at finding intersections, calculating zeros, a whole bunch of good stuff. So the first thing, let's take a look at what function we have. It's 45 squared of x times cosine, blah blah blah. Let's type that in your calculator, but let me show you something. Like, if you mess something up, and suppose you put in there 45, but it's supposed to be 452. So instead of just clearing out the whole thing, like if you forgot to add a 2 right here, something that some kids don't know about is this little insert key. You put where the 2 needs to be. It needs to be 452, so put the cursor right here, then hit second, insert, and then add your 2. And now, without having to clear the whole thing out, you've just fixed it using this little insert key. We can go back and then change this 2 and just delete it back out because we don't really need it. Something else in this course, you want to make sure that your calculator is in radian mode. So click mode right here, or just click and make sure that you're in radians, not degrees. You're always going to be in radians in this class, and that's just a quick check just to make sure that you're in the right spot. For this problem in a few minutes, g of x equals 60. I've typed it in, but if you look at the equal sign right now, I've gone to the equal sign, clicked enter on it. Right now it's on. If you click enter again, it will turn that graph off. So right now it's storing the 60, but it won't graph the 60 or use the 60. That's how you turn equations on and off. Alright, so let's read what we're doing here. It says use the button insert just in case of mistakes, so that's what I just showed you. For this one, it says use the table set button to make, and it looks like I forgot to type something here, but let's go to the table set. That's right above window. And what I want you to do is to change your table to either go by ones, and both of these on auto, so you can see what's going on, like what this all means. This right here, the 0, will tell your table to start at 0 and to go by ones. So I'll show you what's going to happen. So if you click table, this is going by ones here, starting at 0 and giving you all of your function values. If you go back to the table set and you want this to go by halves, you can change this to 0.5 right here, and now it will be going by 0 and then 0.5, then 1, 1.5, etc. That's an easy way to get values that you want. Something else that we're going to do from time to time is change the independent variable over to ask. We'll do that in just a minute once we get to this part, but I'm just going to go back to ones and just at 0. These are both on auto, and we're going to use that for these values right here. It says use your calculator's table to find the value of f of 1, f of 2, and f of 3. All right, well, f of 1 is 44.911. If you go down to this value here, so the calculator table will only do so many decimals of accuracy. So if you highlight it, it'll show you actually what it is here with way more accuracy. You have to be at least 3 decimals of accuracy right on tests and on the AP test to get your final credit. So don't just, like on this next one, 61.63, that's not accurate enough for tests. You go down, it's actually 61.629. The 5 could round it to 61.630, but just so you're aware, 61.63 is not the whole story. So those could be your answers for here, here, and here. But let's go and do this a different way. So it says use the table set and change independent to ask. So let's do that. Independent. Let's scroll down, change this to ask, and now what you'll see on the table is that this is all blank. So you could just type in a 1 and it'll spit out what f of 1 is. So if you want anything, this is just a quick way to get function values without much work. One other way is using the home screen. So if we go second mode, that will quit us back out to the home screen. Something that I like to do a lot in class is to pull up this y1 of whatever value right here, just like f of x. So that is a shortcut button. You hit alpha, trace, you got y1, we're going to use that, of 1, so make sure you put the parentheses around there, and it gets your 44.910. So if you forget to put your parentheses around it, it's not going to give you the correct thing, because y1, what it's doing is multiplying whatever y1 is. It thinks it's a number or something right now. If I just click enter, it thinks it's that, and it's multiplying it by 1 to get this. So make sure that you put parentheses around it like this to get your correct answer. So any of these answers right here just come from the home screen. Just hit alpha trace. We want y1. So you can just click 1 if you want. Add 2 like this. Click enter, and you've got your answer right here on the home screen. You could even go up and highlight and then click enter. It will copy paste, and then you could just go back and edit the 2 to a 3 or to whatever you want, and it gets your answer real easily like that. Okay, so that's some of how the calculator can get function values real quick and easy. Next thing we're going to do is to take a look at this graph and find when does it intersect with g of x equals 60. So if we go back to the y equals screen, let's change this function to on so that it will graph it. You could even see if we go to the table, now the 60s will be there. Or if we go back to table setup, change this back to auto, right here, it's now going to list 60s everywhere in your Y2 slot. So to figure out when these two things are equal, we want to look at this kind of picture and see where they intersect each other. But what you kind of need to think about is, well, number one, what's the domain? And they tell you it's right here from 0 to 6. So the first thing you want to do is to make sure your window is at least 0 to 6. It could be a little bit more. It could be like -1 to 7. As long as you've got something close to that on the screen, we can make that a 7 just to go a little bit further out. And then your Y maximum. This is the one that's going to be kind of tricky to figure out. And your table can help with that. So if you're at 0, you know the lowest so far is a 0, and then up to 6 can be a -70. So we could go all the way from negative to 70 for the low up to like 65 or so for the high. So what we could do is change our Y minimum to like a -70 to maximum of about 70, something like that, just so you have a picture, a decent picture of what's going on. So right here, the blue one is this function here, which I should have done in red, but that's okay. We've got the g of x 60 right here, and you see this intersects 2 times. Once here, it looks like about 1 point something, and then over here, 1, 2, 3, 3 point something. So to do this, we go to second trace, which is calculate. We want the intersection, so we want to go down to number 5, click enter. So it says first curve, we need to be on the first one, the Y1, you click enter. Second curve, we want to be on the red one here. So now it says guess. Well, it needs to know which one of these intersections is it talking about. So we want to either move the cursor over this way, or you could simply type in, this one's almost at 2, so we could even just guess x equals 2, just like that. Click enter. Now it knows which intersection that it's talking about, so we can come over here and type in 1.8 and then the 6. So we want to either take the first 3 digits, which is called truncating, or you could round your answers to the 3 decimal places. So if that 1 was more like a 5, then you could make this 1.867 if you wanted to, but it's always going to be easier to truncate on the AP test, so you don't have to worry about rounding. Alright, so then this other intersection point over here, so what we need to do is just repeat the whole thing real quick. So hit second, calculate, then go down to number 5, or just hit number 5. Needs to be on this Y1, click enter. It's on the Y2, click enter. So you could scroll over till you get to here, or just click 1, 2, 3, about 3.5. That's our guess where the intersection is at. Click enter. And that's going to give us our 3.519 answer. We want that to 3 decimal places, so we're good. We've got 3.519. That's our other intersection place. Okay, and then this little bullet point, if you don't have a color calculator, something that you can do is to make your equations thicker so that it sticks out a little bit better, especially with the gray calculators. It won't do that on this since it's color. Well, you could see like right here, if we click enter, and to get to this line on the gray calculators, if you keep hitting enter, you could get it to a point where the lines will be thicker. So that could be useful, but that's okay. You could see that with your own, but if you have a color one, you can make it whatever color that you want. But otherwise, you can make them thinner or dashed or bolder, something like that on the gray calculators, so that it's easier when you graph these things to kind of tell them apart from each other. Because like with the color, it's easy. With the black and white, it's not so easy. So you can again make one of them bold and one of them regular, just to kind of see the slight difference between the two. Alright, now for the next problem, when you go and calculate a 0, let's take a look at the problem. So this is the same exact function as before, but this time the domain's increased a little bit, 0 to 10. So we'll go back to the window and change the domain to at least maybe -1 to 10 or -1 to 11, something so you can see it. The -70 to 70 might still work. We could take a look at the graph and see if it looks like a good fit. Let's see. So again, we're calculating zeros. So you see there's one right here and one right here. Oops, what we need to do, since we don't want this one anymore, is just to go back and turn this one off, so we don't even need to look at it, just to get it out of our way. Just click enter right on the equal sign, that gets rid of it. Now we'll go back to the graph. And this is 1, 0 going to be right here, and then that's the other 0 right here. And there is going to be a third one, but it looks like it's going to be out of our domain 0 to 10, so we're not even going to worry about any more zeros. So what we do for calculating zeros is click second, calculate, number 2. Alright, so when it says left bound, if we look at this is 1, 2, 3, 4, somewhere right around 5. You want to be to the left side of 5, so if I just click 4, it's to the left of 5. Then it says right bound 6. Okay, so these two blue lines are kind of trapping where your answer is going to be, because we don't want this 0. Now let's just guess around 5. Click that, and then here is our answer. So the answer is not 5, but it is close. So 1, 0 is x equals 4.993. And the other one, let's go figure out. So let's go back to calculate the 0, number 2. And so that's 5, 6, 7, 8. It looks like it's in between 8 and 9. So we could do left bound. We could even do 7. Right bound, it could be 9 or 10. Just throw 10 in there. And for a guess, so we've got this line and this line trapping the 0, so we could guess around 8. And if your guess isn't in between them, it's not going to work, but this is a good guess. So the 0 is 8.648. Or on the AP test, since that's a 6, They also give you credit for 8.649 for this zero right here and this zero right here. So I'll let you try 4041 and see if you get those correct.